If you like our content, please like, subscribe, and click the notification bell to get alerts when we introduce new videos.
Welcome to Module 2. In this module we're going to cover how you do an installation of the RUCKUS IoT Controller in a Linux KVM environment using the versh command line interface. Okay, so the first thing we're going to do with a KVM install is we're going to actually be using the command line to do the install rather than using the GUI interface or the virtual manager dashboard interface. So the first thing we need to do is to find the IP address of our local machine. So we can do that with ifconfig. Okay, so ifconfig gives us a list of all of our local ports within our Linux environment. And the key thing here is we have our bridge with an IP address defined here as 192.168.111.10. So we have a bridge and we have one port, and then we have a second port which is connected to the KVM virtual machine. So we have both our Ethernet ports and our virtual machines both connected to the bridge on this IP address. So we're going to need to use both the name bridge 0 and the IP address as we configure our KVM and get access to the rest of the system. Okay, so the next thing we need to do is to actually make sure the virtual machine manager is running. So we do a versh list --all. That will list all the virtual machines that are currently running in the KVM environment. So we can see currently I have one IoT controller that's configured, but that's currently in a shut-off state. So what we're going to do is we're going to create a new virtual machine. So we've downloaded the IoT controller image from the RUCKUS support site. If we do an ls, you'll see that that's in here, and you can tell that it's for KVM because it has a QCOW2 within the file name. So you're noticing it's an IoT controller for QCOW2 and then the version number. So we're going to install a 151 build for this particular installation. So the first thing we need to do is we need to unzip this image. So we do a tar xvf and then the file name that we're trying to unzip. Okay, so that'll take a few seconds. And then once it's unzipped, you'll see we now have the files unzipped. And the key thing here is we have two files. We have the QCOW2 image, which is actually the image for the virtual machine that's going to run on the KVM virtual machine manager. And then we also have this XML file. And this XML file contains everything that's needed for the virtual machine to be installed, provisioned, and set up within the KVM manager. But before we can actually run that, we actually need to modify it. So we need to make a few minor changes to this for our system and to match into our network configuration and setup. The first thing we probably want to do is we want to change the default name. So it's all well and good having the default, but if you're like me and you're running half a dozen different versions, it's quite handy to have different versions, different strings names for them. So I'm going to call mine RUCKUS IoT Controller, and then I like to keep track of the firmware version that we're running. The next thing we need to do is we can change some memory. So by default it's configured with 4 GB of memory and 4 virtual CPUs. Now depending on what we're going to be doing with our platform, we may want to increase those settings to give ourselves some more memory and some more virtual CPUs for the application. Next thing we need to do is we need to set the default path of where the QCOW2 image is located. So within the system we've defined where we've unzipped the file name. Now by default you would install that into the default KVM environment within the machine, but I'm going to run mine from the local path. So I'm just going to paste in the local path file name. So it's within the local path of my local machine, and then pointing to the QCOW2 image that we've just unzipped. The next thing we're going to do is we're going to set up the Ethernet port and attach that to the KVM. So in the section here we'll see there's an area called interface. Now what you can see is by default it's set for a network and a default configuration. Now we've just discovered that ours is configured with a bridge, so we'll need to slightly change the configuration. So there we go, that's the new configuration. We'll go through this now. So we'll delete the old configuration and we'll look at the new. So we're telling that it's attached to a type bridge. Now we've also defined a MAC address for this particular virtual machine. You don't have to do this. By default you can leave it as a blank and it will just come up with the next arbitrary MAC address, but it's quite useful to allocate the MAC address at this point when we're defining the system. Because we're using a bridge, we need to tell the KVM manager the name of the bridge port, so we're going to be attached to bridge 0 as we discovered when we did an ifconfig, and then we have some default configurations for the type of network that we're using. So we're going to use a virtual interface and some just default settings for the way for the KVM manager to provide those. So these are perfectly valid and usable configuration settings. That's all we need to actually configure in here now. So we'll save this file, and we'll see as we do a list, we'll see we have our XML file and we have our QCOW2 file. So the next thing we need to do is we actually need to onboard and create the KVM virtual machine. And the way we do that is we use the virsh command. So virsh is a command line interface to the virtual machine manager. And what we need to do is we need to define a new virtual machine, and we point it to the XML configuration file that we've just modified. So we're going to create a new machine and use all the settings that are in that XML file. And that's now completed. Now, if we now do a virsh list all again, so list all the virtual machines, we should now see that we have our new machine that's being created. And that is now set up in operation and ready to be started. So now we can actually start that machine. And so what we do is we do virsh start, and then we use the domain name that we've defined. And this was defined in the XML file that we created earlier or modified earlier. So this is how we now start, stop, and talk to this particular machine. So we're going to start with the virsh command that particular IoT controller name. And we're started. So now if we do a virsh list, okay, and we've done a list versus a list all, we can now see which machines are running versus a list, which gives us a list of all machines. So we can now see that that machine is now running and is operational. So that completes the initialization, startup, and configuration of the RUCKUS IoT controller. Okay, so now we actually come to our DHCP server. So what we're doing now is we're looking at our DHCP server on our local area network, where we've just started up our IoT controller. And you can see in here now that we have that MAC address that we created, 525400BBAB18, and you can see it's been assigned this IP address. So the IP address 192.168.111.13. Now that is the IP address now of the RUCKUS IoT controller that we've just started. Now that is a very quick way using this particular setup that we can find the IP address of that machine. So in some situations you might not have direct access to the IoT controller or to the DHCP server to tell you what the IP address of the machine has been assigned, or the IoT controller has been assigned. So in which case we can use a tool called Nmap. So Nmap is a Linux capability, or a Linux tool, which can be installed using the standard Ubuntu or Linux operating system install capabilities. So what we can do is we can run Nmap with a -SN, and then we use the IP address domain of our local area network on our Linux machine. So it's 192.168.111, but we're going to look at all IP addresses within the subnet that we have on this particular machine. So when we run this, it will now report back every single device that it can find on the local area network. So here you can now see every single device's IP address and its MAC address and the manufacturer. So this is based on an OUI lookup of the MAC address, first digits, and determining who the manufacturer is. And as we go through the list, you'll see that there is a device that is listed as a QMU virtual NIC, and that is on 192.168.111.13. Now you can see here that that MAC address, it starts 525400, which is the standard Ubuntu KVM Virtual Machine Manager OUI, and then the 3 digits that we defined for the MAC address. So this is the MAC address of the IoT controller that we created, and this is the IP address that it has been assigned. So if you don't have access to the DHCP server or to your DHCP to find out the specific IP address of a device, there are tools or capabilities out there using standard Linux tools that will scan through and find that device within your network. So now that we've got the IP address, we can actually now log into that. So we will log into 1.1.13, and you'll see we're saying the connection is not private. That is because the certificate on board is currently not recognized by the browser, so we can bypass that and accept and proceed to the website. So we've now connected to the IoT controller, and you can see the version and the date and time. And now we're actually into the initialization phase of the IoT controller. So now we can set up all the services and configuration options for this particular IoT controller now as we bring it online. So the first thing we can do is we can choose any of the services that we specifically want to use or want to disable. Now, the most interesting, obviously, most of these we need for general operation of the application and for the IoT controller itself. But one of the key things we have are the two additional services. So our rules engine, we can enable or disable the rules engine, and the Track Central, which is the LoRa network server capability, is also in here. So we can click next on that. The next thing we can do is we can set up all of our local settings and configuration. So the first thing we can do is give it a local host name. So in this particular case, I'm going to call mine 1701A5. Okay, so that just gives myself a local IP, like local name on the host name within the network. I can also set up the local time zone. So I'm going to set mine up for my local time zone. And the next thing we can also do is we can set up a network timing protocol connection. So this actually is very important for synchronization of the controller, the access points, and all the events. If devices, access points, and controllers all get out of sync, you can end up with consistency and reliability problems within the network. So it's very important to set up the network timing or some kind of timing configuration within your network. So you can either set the time manually, or you can use an NTP. You can leave this as an optional address, or you can set your own. So I can, for example, use the Google server for helps if I spell it correctly to set up the local NTP time server address. And then additionally, we can set up the IP configuration. So I'm using DHCP in my configuration, but we could bypass that and actually now manually or statically set the IP address of our controller. Next, we click next. So next, the final thing really we need to do now is to set up the authentication, the username and password. So by default, the account is set up with a username called admin, and you now need to define a password for that administration account. Now, again, you need to use a complex password because of the legislation in the US around securing environments. So again, we'll set up our username and password within the IoT controller. Okay, and again, if you set these up wrong or incorrectly, it won't allow you in. So you need to remember this, otherwise you're not going to be able to get access to the controller going forward. And that's it. So now we're basically ready to go. So here's our end user license agreement, which obviously everybody will read. And we need to move on and click accept. Now at this point, we will now provision the platform and configure it and then restart the system. Okay, so now you can see after a period of time the IoT controller reboots after the configuration, and you get the services starting. And then within a few seconds of that, you'll see the IoT controller provides you with the login information. So the system has now configured, restarted, and is now asking you to log in. So again, we can now log in using the username and password credentials that we created during the initialization script. Okay, and the IoT controller is up and operational. So what we've done now is completed the installation of the IoT controller in a Linux KVM environment, and can clearly see now that the system is up and operational. The next step is obviously now to configure our services, our applications, and then to start onboarding our access points and devices and our rules and applications.